Generative AI refers to artificial intelligence systems that can create new content, such as images, text, or music, by learning from existing data. At the heart of these systems are two main learning paradigms: supervised and unsupervised learning. Supervised learning relies on labeled data to guide models towards specific predictions or classifications, while unsupervised learning allows models to discover patterns and relationships without explicit labels. Understanding these approaches lays the groundwork for appreciating how generative AI develops its creative capabilities. Supervised learning involves training models with datasets where each example consists of an input paired with the correct output. Through repeated exposure to these input-output pairs, the model learns to recognize features in the data and associate them with the appropriate outcomes. This process enables the model to adjust its internal parameters, enhancing its ability to make accurate predictions when faced with new, unseen data. The effectiveness of supervised learning is closely tied to the availability and quality of labeled examples. A practical example of supervised learning is teaching a computer to identify animals in photographs. By training on thousands of labeled images, such as cats, dogs, and birds, the model learns to distinguish between different species based on visual features. Once trained, it can accurately classify new images, streamlining tasks like image sorting and supporting applications in fields like medical diagnostics and security. Moving forward, let's see how learning can take place without labeled data. In unsupervised learning, models work with data that lacks predefined labels or categories. Instead of being directed by known outcomes, these algorithms search for patterns, groupings, or underlying structures within the raw data. This approach is particularly valuable when labeled data is scarce, as it enables models to reveal similarities, differences, and relationships that might otherwise go unnoticed. Techniques such as clustering, dimensionality reduction, and anomaly detection are all powered by unsupervised learning, which is also fundamental to many generative AI models. For instance, unsupervised learning can be used to segment customers based on their purchasing habits, age, and location. The algorithm organizes customers into clusters, like frequent buyers or those with specific preferences, without any prior knowledge of their categories. These insights allow businesses to tailor marketing strategies and recommendations, uncovering valuable patterns that labeled data alone might not reveal. This ability to find structure in data is especially important for generative AI systems. Generative AI models frequently utilize unsupervised learning techniques to grasp the distribution and structure of data. Approaches such as generative adversarial networks and variational autoencoders analyze vast amounts of unlabeled data to extract essential features. By internalizing these patterns, generative models can produce new images, text, or audio that closely resemble authentic examples. This capacity to generate realistic content highlights how unsupervised learning drives innovation and creativity in generative AI. In conclusion, supervised and unsupervised learning are two foundational approaches in machine learning, each fulfilling unique roles. Supervised learning is ideal for making predictions or classifications with labeled data, while unsupervised learning excels at uncovering hidden structures in unlabeled information. Together, these paradigms empower generative AI to both refine outputs and discover new patterns, making them essential for harnessing the full potential of artificial intelligence.